All right. Hello, everyone, and welcome to the stream. I hope everybody is doing well tonight. We are back after a week off. Wasn't feeling so great last week, and then I decided to also take Thursday just to sort of take a little bit of personal time and reflect on some of the things that I need to do. Sometimes it helps to just kind of walk away from it for a little bit and then come back. So we are back. Pale Blue Zebra, good to see you. So we're going to pick up more or less on what we were working on last time. I do want to discuss something a little bit different, but still related to what we've been working on in previous streams. But before I do that, I do want to give a quick thank you to the supporters of the channel, starting with our elite partner, Javier Alazaron, followed by our partners, Gabolis Inc. and Matt Oscard. They are the highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It's greatly appreciated and helps me cover costs associated with running the channel. Things like software licenses, hosting fees, occasional hardware needs, things like that. So thank you all very much for that. It means a lot to me, and I greatly appreciate it. That being said, I do also want to thank all of you, the viewers, whether you're joining us live here on the YouTube side or the Twitch side. We do simulcast to both, or if you're catching the VOD after the fact, thank you guys very much for being here as well. I appreciate you guys being here because without you guys, this project and thus this channel would not exist. So, all right. So, with all of that said, what we're going to be tackling tonight is we're going to be speccing out a new model format. And I've done a little bit of thinking about this offline and how I want to handle this because I wasn't really 100% happy with the sort of divergence between our standard sort of static meshes and our animated meshes. And I was thinking, there's going to be a lot of duplicated logic and a lot of duplicated data structures between the two that doesn't really need to be there. And so I think it makes a lot of sense for us to go ahead and combine those two into a unified file format. I think it makes a lot of sense, right? And so what we're going to do is we're going to spec out the file format and what that looks like, because I think that that's really important to kind of get right first. And then we'll go ahead and code it, and then we will switch everything over to use it. What this is also going to allow is it's going to allow us to have a single serializer for all of the various different types of models we use. And it's also going to allow us to handle these models, in a unified way, whether they're animated or not. And we can then also essentially eliminate our static mesh system and unify that with the animated mesh system that we wrote. And we might just rename it to something that's a little bit more unified as well. So this was something that I was kind of thinking about. And this is one of the reasons I kind of wanted to take a little bit of time to think about this before I did it. But the more I thought about it, the more that this just makes sense to do. So let me see. Xerox Cafe Babe is also the magic number starting bytes of Java class files intentional. I just chose that one because I thought it was funny. I didn't actually know that about the Java class files. That's funny. RCW, good to see you. How's it going? Penguin Operator, good to see you as well. Welcome. Yeah, I just kind of chose this just because I thought it was funny. I think that's what Jonathan Blow also uses for his assets, and I just kind of went with it. So, maybe I'll change that at some point, but we've got several other of our assets that actually use that same thing. So, at this point, it's actually literally hard coded into, or I should say, it's defined. Let's see. It's also defined in our item DB. And Yeah, there it is right there. So our asset magic, right? So it's actually literally defined in our code base. And then we also have a 64 bit equivalent of that, which is just 0x Cafe Babe bad coffee. So there's that as well. All right. So the more I've been thinking about this, the more I thought it made sense to, have this sort of unified file formats. And I got thinking to myself, we have the KSM. We were talking about a KAM for static and animated mesh. And I got thinking, I'm like, okay, well, what would the sort of two of those be? And I'm like, I don't really just want to say mesh because that doesn't necessarily cover everything that we may support in this. And so I came up with K3D as the format, right? So that's K3D is Kohi 3D model format, right? And so the extension of that would be K3D. And I started sort of writing out the spec document. I didn't get very far with this because I did spend a lot of time just kind of thinking about how I wanted to combine it. So this is kind of what we're going to work through tonight. It's a little bit different than some of the coding stuff that we normally do, but I feel like if we think about it, we get a spec written out this way, then we can always just easily refer back to this when we're actually, going through and implementing it, right? The other thing that this is going to do is it's going to serve as documentation to go along with the engine. So I figure documenting it this way serves both of those two purposes, right? Any reason to not use a more common format like GLTF or OBJ? Yes, there is a reason for that. Good question. First time chatter, welcome, by the way. So the main reason for that is you have to parse and process those things. And so what we want to do here is we want to essentially have a binary format that is as close to the game structure or the structure that the engine actually expects it to be in, right? So we don't want to have to do a whole bunch of translation between data types. OBJ, for example, is straight up text parsing. GLTF GLTF is also straight up text parsing, unless you're talking about GLBs, which is the binary format of that. And I do want to support those for imports, but those in the end are not the format of data that we want to have as far as what the actual engine is going to expect. So I want to make this format in a, where the data is already laid out in memory in the way that we're going to use it. Ideally, you just mmap the file. Yeah, essentially, yeah. It's not going to be quite that simple because there is a little bit of serialization and deserialization that has to happen. But for the most part, when I have an array of data, I want to be able to just read in the array of data as an entire block of memory, right? And so there's going to be a little bit of parsing that happens, a little bit of checks that we're going to have built into the format to make sure that we've got certain checkpoints throughout the data to ensure that we're doing things the right way and we're not overreading from it or underreading, things like that. But for all intents and purposes, that's the reason that we're doing it. And also, this is designed to sort of be an educational kind of thing on how you would attempt to do something like this, right? So we've kind of looked at this briefly before where we kind of ad hoc just made up our formats as we are coding, and that was fine. But the disadvantage to that is, when you come across something else later down the road and you want to add to that, maybe it's not quite so easy to add to it in a way that makes sense, right? And so I'm going to try and kind of work through a lot of those problems ahead of time as much as possible in the format so that when we get ready to write the parser, it's not that big of a deal. I keep calling it parser. It's technically like a binary serializer. You can think of it that way. Black Maestro, good to see you as well. How do you feel today? I feel much better. Thank you for asking. I am having a great day. I appreciate you asking. I hope you are as well. Welcome. From Lake and Singy, good to see you both. How are you guys doing? All right. So This was basically as far as I got in terms of writing the actual document. So that's what we're going to be working on. And that is why we have HTML over here. So this is going to be dirt simple. I started kind of, banging out some of this here. It's just going to be tables, nothing too crazy, right? And so what we've got here is I've got the header of the file format defined here. And so it's got a magic number that we use to, mark the file as a Kohi asset. So that's going to be one of the first things that we check to make sure that it's actually as we expect. We also have a asset type in here, which is the next thing, and we're going to have a new asset type K3D. That's going to replace our static mesh and our animated mesh. It's all just going to be K3D. Then we have the asset version, so we'll use that for whenever we go ahead and add features to it. We'll have, at some point, we're going to be having exporters for this. So I want to have some way to sort of identify the exporter used. So at some point, we're going to be writing probably a Blender exporter so that we can export to this format directly from Blender. And so I want a way to just sort of track that in the file format. And then we've got a couple of other higher level things here as well. So we've got extents, right? Some extents of all of the submeshes combined.
Hey Travis and chat.
Apotham, good to see you. Thank you so much for the tier 1 sub. 9 months. I really appreciate that support. Thank you very much. It's great to see you. So we've got the extent 3D here, which is essentially the combined extents of all of the submeshes that are contained. And then we have the sort of center point of all of the submeshes. And then we have the inverse global transform. And then we have the submesh count, bone count, node count, animation count, and string count. And the string count is something that I also want to talk about because this is something I did do offline. And so we actually have something that's been added called the binary string table. And what this is it is a essentially a block of memory, or it could be serialized to a block of memory rather, that manages a bunch of strings. And the idea behind this is to be able to store the strings in a binary file, tightly compressed, or I shouldn't say compressed, but tightly packed with no terminating string data. And we can essentially load and write this to and from a binary stream, essentially. And so the idea behind this is that we can create one, or we can create one from a block that already exists that's maybe been read in from a file. And to that, we can then add strings. So if we've created a new one, we can go ahead and add strings to that. And then we can also, from those, whenever we add a string, we are given an index or sort of an ID of where that string is stored in the table. And then we can use that index to retrieve back the string, the original string, or the length of that string. And so we have a lookup there. And then we can also retrieve the value of that string into a buffer if we wanted to do that without allocating memory. And then we can also take and serialize that entire thing into just a single block of memory that could then be reloaded into this binary string table from block. So the whole purpose of doing this is for file formats just like this one that we're going to be making, where we have things that are named. So like meshes, bones, nodes, things like that. Things that are referred to by name. In the actual file format itself, we will store the name as an index, and it will be an index into one of these tables. And then this table itself will be serialized, and that block of memory will be stored all the way at the end of the file. And so I've already written all of this. I'm pretty sure it works, although I haven't tested it yet, so we'll figure that out. but it's relatively straightforward as far as the implementation goes. It's only 130 lines of code, right? So there's not really too much to talk about here in terms of how that's actually set up. It's really just let's go here. So all this is in terms of its in-memory representation is it's got a header which has the number of entries and how large the data block size is. And then it's got an entry lookup, right? So we can take this is essentially the lookup into this block of data here, right? And so this is where all the string data is actually stored. One string right after another, not terminated, right? And so when we look up a string, we say, okay, we want string ID 3. We look into this lookup table. That will give us an offset and a length. We can then use that to retrieve the string. So, it's nothing complicated at all. It just sort of is very simple, but it's also a way for us to not have to manage this stuff inline in all of our sort of file parsers, deserializers, what have you. Yeah, Stella, you mentioned somebody else mentioned that too. Same number as the Java bytecode. I may have to change it just so that I don't use that. I didn't realize they used that, but yeah, it was Pale Blue Zebra that mentioned that. But yeah, I might have to. I might wind up having to use a different magic number, but all it really is it's just the first couple of bytes in a file that tells me it's a Kohi asset, right? So I could change that at any point as long as we standardize that before we release. That's all that really matters. Technology hates me this week. I have had my Arch Linux laptop, my old Windows 10 laptop, and my Android phone battery all stop working in the past 6 days. Jeez, Apotham. Are you giving off like EMP energy or something? Is there like an EMP field around you or something that you're not aware of? That's crazy, man. Although I've had similar luck on occasion, so I feel your pain on some level. Orshi, good to see you as well. How you doing? Okay. Anyways, so that's how we're gonna handle storing our strings. So that's that. So basically what I want to do tonight is kind of go through and work out this format. So we have the header bit. So we probably ought to go in here and do the next bit of this, which is probably going to wind up being, we're going to need another section down here. So I'm going to put this here. And you'll note that I don't get fancy with all of these, the newfangled way of doing things where everybody likes to treat divs as tables. Homie don't play that, right? I want to keep things, as simple as possible, right? Raw HTML is the easiest way to document things, I think. Aside from Markdown, which I actually did try doing this in Markdown, and it wasn't very easy to format, so... you heckin' love binary format specs. Awesome. That's what we're doing tonight. So let's see, instead of header. So the next thing, there's a couple things we have to work out. And actually I do have some notes here. Cause I started writing this out and then realized, you know what, this format that we're kind of copying from the other static mesh format's not going to be the way to go. So we have bones, nodes, animations. And then we also have our sort of submesh data, right? So I think probably the first thing that we should do is probably, I guess, submeshes, right? And so let's put this here, submeshes, and then let's also add that here. Submeshes. right? Okay. So submeshes, we already have a submesh count, right? So what we need to think about here is all of the data for our submeshes and what we actually need to store in those. So if we take a look at the K-asset animated submesh data, that has in it a name, material name, a vertex count, the vertices, index count, indices, center, and extents. So the problem with this is we can actually store all of this stuff reasonably in essentially a structure of arrays, except for the arrayed data where we have vertices and indices, right? And so the way that I want to handle this is a little bit atypical, I think, but I think it makes sense. So what we're going to have is, since we already have submeshes, the count in the header, and I think we can probably leave that there. I want to store essentially we'll do name ID, right? And this is going to be the string ID of the name of the submesh. And this is going to be an array of string IDs of the names of submeshes, right? So, you know, length equals submesh count, right? And so what we're going to do is we're going to store those things contiguously. So we should probably say name IDs here, right? Oops. And so what we'll do is for size, we're going to say 2 times submesh count, right? And actually, do we have... I think we literally just called it...
You dingus.
Yeah, just submesh count. That's fine. So that's going to be the size of this sort of field, right? So this field is going to be an array of those things. Let me just make sure that that shows up as we expect, right? So we have name IDs. The number of bytes is 2 times the submesh count. The data type is going to be a U16, and then an array of string IDs of the names of submeshes, right? So that's going to be the way that we're going to store a lot of the data, with the exception of the vertex and index data. So we'll get to that in just a second. So let's take this, and we'll do, instead of that, we're going to do material name IDs. That again is going to be the same type and size. And this is going to be of the material names of the submeshes, right? So that's that. And then we can go down here. And the next thing we're going to say is we're going to do vertex counts, right? Because we can store that, right? And again, that is going to be, let's see, you know what? We have, that is a U32. Okay, so we're going to have to change that. So that's going to be 4 bytes, and it's going to be a U32. Still going to be 4 times submesh count, though, right? And that's going to be an array of counts of vertices per submesh, right? So again, that's going to be an array. Same thing is going to be true for index count, right? So that's just going to be the same thing. Index counts, and then this is going to be indices. All right. So we have that. That makes sense. Let's see. So the next thing is going to be, we're going to skip vertices. We're going to skip indices for now. We'll do, I guess we'll do centers, right? So we'll do center positions per submesh, right? So this is going to be, it's a vector 3, so it's going to be 12 bytes, right? So we'll say vec3. Make sure I got that right. Yeah. And then we are doing one more thing, which is going to be extents. So this is going to be an array of, whoops, this should be just that. Extents per submesh. So this is going to be 24 bytes because, 24 bytes because extents 3D is 2 vector 3s. So we have that, right? So all of these things just kind of line up nicely. One more thing that we should probably add in here is we want to talk about, let's see, submesh counts, name IDs. Yeah, let's do, in front of name IDs, yeah. First here, I want to add something that's not in this list, which is going to tell us, we're going to say mesh type, right? And this is going to be just 1 byte, right? So it's going to be a U8. And this is going to be an array of types of the submeshes, right? And so what that's going to tell us is what the format of the vertex is going to be. So we'll say, for example, 0 equals vertex 3D format. 1 equals skinned vertex 3D formats, etc. Right? And in case we have any other vertex formats, that's essentially what that's going to be, right? So that'll tell us exactly what's going to wind up here, because we're going to unify this data here. How about storing it in C code? What do you mean? What do you mean by that? Web dev? I don't know if I'd call this web dev. It's really documentation, right? Is what we're really building here. Why do you need it to store the center? Wouldn't it be better if the vertex positions are already stored centered? So what the centers and the extents here are really for is for us when we're doing any sort of spatial partitioning or something. It gives us a sort of average of what all these things are. So when I say center of this, it's basically the midpoint of the extents. So when we are importing the geometry to this, we basically look at all the vertices and we say, okay, well, what's the minimum XYZ and what's the max XYZ? And we store that in the extents. And then the center of that is just the midpoint of that. And so if we need to extract that for any reason, for any of the submeshes, we have it. And then at the top level, we also have extents and center. And this is essentially the extents encapsulates all of the submesh extents, and then the center is essentially the midpoint of that global extents. Yeah. So I hope that makes sense. Terrible run of luck. Cyber Week is not too far off in the future. Yeah, I mean, that's true, RCW. Yeah. That's true too. It's a good time to buy some stuff as long as, well, yes and no. Because I've heard mixed things over the years about that. I know there was an issue with, I think it was Samsung drives, or was it Samsung SSDs? I think it might have been Samsung SSDs. Where there was a run of like the Cyber Week, Cyber Monday drives that were on special that they like borked. That went bad. And mine was one of the ones that was affected by it. Like, this guy here is dead. And I traced it back to that from like, I think it was 2023. But yeah, so you do have to be a little bit careful about that. Let's see. Binary format programming, hell yeah. Awesome. Welcome. Why is it a U16 though? So, why is what a U16?
You dingus.
Are you talking about all of these name IDs and stuff? If you're talking about these two, I don't want to do a U8 and be limited to 256 of them, right? Because there is the possibility that we have some sort of really complicated submesh or mesh that gets imported with more than 256 objects in it. Yeah, so and this isn't just, so this is like all strings in the entire file, right? So if you had a complicated setup where you had something that had, 100 bones in it and I don't know, 200 meshes in it, you would have already blown that out of the water, right? And there's other things that nodes and stuff can be used for as well besides just animation, but I didn't want to limit that to 256. So I figured U16 is reasonable because that'll give us, 65,536 possibilities for names. And I figured that's probably enough, in terms of named things. So yeah, I hope that makes sense. Hydrate. Thank you for that redeem. Let me see. I will do that. Appreciate that. Okay. So, we have our index counts and our vertex counts. But we don't actually have the arrays of these things. And that is what I want to put down here. So let me think about how I want to do this. So we actually need 2 bits of information from this, which is going to give us what we need. So down here, I guess let me think about how the order of operations here. Let's do it this way. Let's do what I'm going to call 2 buffers at the end of this, right? So we're going to have a vertex data buffer, right? And this is going to be 4 times, well, actually, we don't have a specified size on this, times number, or actually it's gonna be, how do I want to put this? So essentially this is going to store a bunch of F32s, right? And so this is going to be a buffer of F32s that stores all vertex data for all submeshes, regardless of format. the overall size of this is determined by the vertex formats of each mesh, submesh. How many vertices that submesh has, as well as how many submeshes there are, right? So we essentially have two of these, and they're basically going to be a large buffer of just flat data, right? So we have an index data buffer here as well. This is going to be a U32, and this is going to be a buffer of U32s that stores all index data for all submeshes. However, format on these does not vary, right? So that doesn't mean as much. Overall size is determined by the how many indices each submesh has, as well as how many submeshes there are, right? Okay. So essentially what that means is that each one of these submeshes is going to have a vertex count and a vertex offset, right? And so this is going to be, again, a U32 offset into this large buffer down here. So this is basically going to be how many bytes into that buffer are we? I think a U32 is going to be enough here. If not, we may have to extend that. But this is going to be an offset into the vertex buffer. An offset into the vertex buffer where the vertices for a submesh begins. And the length of this is actually this part of the thing is still accurate. All right, so we have that, and then we have the index version of that. Right, so this is going to be index offsets, and then this will be index buffer, where the indices for a submesh begins, right? So what we'll essentially have is everything will be crammed into these two buffers here, and we'll extract what we need from those buffers. The only thing that we might have a problem with in the vertex buffer is in our skinned vertex 3D, we do have, let's see, this is all floats. These things here are all floats, right? This, however, is a signed integer, right? Or signed four signed integers, right? So even though our buffer says it's of type F32, we're actually going to wind up having an I32 in there as well in the case of skinned meshes. But that's fine because it takes up the right amount of space. So what we're going to have to do is, as we're reading that, we'll just have to be mindful of or I32 of which type we're reading at the time, as we sort of step through that. So that is kind of the format that we're looking at for how our submeshes rather are going to be iterated through. So essentially what that means is as we go through each one of these submeshes, we're going to say, okay, how many vertices are we getting? And then, what's the offset into this buffer for that particular mesh, right? And then we'll use that to, iterate how many vertices according to the mesh type, which will have the type of vertex that we're actually going to extract. So I hope that makes sense. Do you usually stream at this time of the day every day? I stream twice a week, but it is around this time, yes. To the power of 16 meshes sounds like a problem. Yeah, I mean, I can't I can't see having that many meshes, right? I was actually thinking, like, for submesh count, I could reasonably say, maybe we could impose a limit of we could impose a limit of 256 by saying this is a U8, right? But like, I don't know if I'd necessarily want to do that. I want to keep this format open to, expansion. So I'm not really going to worry about that, I guess, for now. Okay. Like I said, some of these things, like some of these offsets, I might need to use a U64 here for some of these things. But yeah. All right. So that's going to do it for submeshes. So that's how we're going to get our data there. The next thing we need to think about is, let's see. Next thing we need to think about is we have bones, nodes, and animations. So I think bones were probably the next easiest thing to get. Did I actually do? Yeah, so I have some type def structures here that I was thinking about using. I'm wondering if I even need this bone ID. I don't think I do. I think all I really need is the offset matrix and the name string ID. And then, each one of these mesh nodes. Oh, that's something different. All right, let's do bones first. I think bones makes sense to do next. Because that's going to be really straightforward, actually. So let's actually just take the beginning of this. So we're going to say, let's go down here and do table. And up here, we're going to do bones. And up here, we're also going to say bones. There we go. All right, so bones. If you take a look at the type for this, so bones have a name, an offsets, and an index into the bone array. I don't think we need to store that in the file. I think we can extract that ourselves. So this is actually going to be relatively simple. So I think what we can do is, I think we can actually do a little bit of copy pasta here. So we can take this guy Actually, I'll say, yeah, let's do this one. So here we'll do name IDs, right? So that's going to be the bone name. So this is going to be an array of string IDs of names of the bones. Length is bone count. And this is going to be bone count. So that's fine. And then we'll do one more of these, where we'll store the offsets, right? So this I don't think I need to buffer the data for, because we're only storing a single mat4 per bone. So I think I can literally just do offset matrices, right? So this is going to be, the size of this is going to be 64 bytes times bone count. This is going to be a mat4. And we're going to have an array of offset matrices of the bones, right? So that should be relatively simple. And that's all we actually need to store in that section. Pretty straightforward stuff. The next one is going to be nodes. So nodes actually have a hierarchy. So that is going to be a little bit trickier, right? So essentially what we're going to have to do is we're going to have to store something that's very similar to this, minus the child count and children. So essentially we're going to store name, the local transform of the node, and then the parent index. And so this is used for sort of hierarchy purposes. So I think we can do something very similar to this. So I'm actually just going to copy this whole section. Let me see. Let me just catch up on chat for a second here. Learned a lot about Vulkan from your Kohi videos. Thank you, by the way. I appreciate that. I'm glad you were able to learn from them. Interested in following your game engine tutorial, but 311 episodes is a lot. You weren't kidding. Yeah. About what episode do you think I should go up to just to learn basic game engine features I can reuse? So we switched away from tutorial format to live stream format around episode 100, I think. I don't remember the exact episode number. But a lot of those episodes are pretty short too, because we kind of started off in a tutorial format and then we switched to doing it live stream. Just because tutorial format didn't really work past a certain point. So you definitely don't have to like go through all of those to get the basics, right? I do know that we laid the groundwork for a lot of our systems that we were going to need before even touching Vulkan at all. And so that took quite a few episodes as well. You know what? I'll do one better. Give me a second here. So I'll go to the playlist. And actually, can I just do... I guess I could just pull this up. All right, so we have the playlist here. If I could just scroll down through this, we set up our math system. We set up, input, windowing, all that good stuff. Event systems, all that good stuff. I don't even think we touch I don't think we touch Vulkan until like, what is it, 13? Yeah, 13. You'll definitely want to go through all of that. We clear the screen at episode 21. And then we had, let's see, we do material system. Yeah, I mean, you probably are going to want to go through. I'm trying to remember if we got PBR in before we switched to live stream formatting. Reasonably speaking, you're probably going to want to go through most of the non live stream stuff. I'm trying to figure out exactly where. Okay, it looks like we started live streaming at episode 88, it looks like. 87. Or is it before that? It might be before that, actually. I would say probably the first 100 episodes, though, are probably worth going through. But then again, just kind of go through, like I tried to title the individual videos of what we're accomplishing in that particular video. So, use your best judgment after a certain point. But I hope that helps. The thing is that it's kind of like once we kind of broke out of the tutorial format, it's a little bit ad hoc just because that's kind of the way it is in reality. Okay. All right. So we have the bones. The next thing we were going to do. Thanks so much for making that and making such a in-depth game engine tutorial. I appreciate that. I appreciate the kind words. It is a lot, but so is creating a game engine, right? Because we do basically everything from scratch here, with the exception of a couple of things that we talk about along the way. But most of these things we do from scratch, and that takes a while. So, let's see. So bones, we were going to do nodes next, right? So let's call this nodes. And we'll call this nodes. And I'll go to the top and just add that as well. All right. So nodes are going to be a little bit similar, right? So we have a name and we have a local transform, right? So we're going to call this local transforms. And again, that's going to be a map4, and this is going to be an array of local transform matrices of the nodes. Nodes. This needs to also say nodes. And then this actually needs to say node counts, and this needs to say node counts. Did I miss anything else? Yes, I did. That needs to be node count. That needs to be node count. Cool. All right. So we have that, and then we also want to store the parent index. So I guess we should probably put that before the matrix. I guess makes sense. So the parent index here is a U32, which I think is a little bit extreme. I feel like these should probably be U16s, right? We're not, like, we don't need to be occupying that much space. So here we are going to say, and that's probably going to break a couple things in my code, but that's fine. We can fix that later. We will say parent indices. And we're going to do 2 times node counts, array of indices of parents of the nodes, right? And so there's 2 ways that we could handle this, right? because not every node can have a parent. And so what we're saying here is invalid ID equals root, which is probably what we're going to stick with. This should probably be invalid ID U16. I think we'll probably stick with that, because the other way is to say, well, let's just make this an I16, right? And then say if it doesn't have a parent, it's -1, right? But that literally cuts our range in half, just to have a negative number. So we can also say here, invalid ID U16 equals root node no parent. I think that makes sense, right? And so this is going to be an index into this very same array to say what its parent is, right? And if it's set to invalid ID U16, then that means it does not have a parent, right? So if we look at this again, now we have our node section. So this is pretty straightforward in terms of format, I think. Not a whole lot to discuss here. What we are going to have a lot to discuss is in the animation data, right? So the animation data, as you may or may not recall, is sort of layered in what it actually contains. And so what we have here is each animation is represented by this struct by the time we actually extract it, right? So each one of these animations has a name, a duration, ticks per second, right? How many animation ticks per second, and then the number of channels, right? And then if we look at what a channel is, the channel is what has essentially our keyframes, right? So it has a name of the channel and then all of our keyframes. So our positions, our scales, our rotations. And then if we take a look at each individual of these, like these are arrays, right? If we take a look at those have a value and a time associated with them. And so the way that I'm thinking about this is we need to essentially flatten this entire structure. And if we think about how we might accomplish that, ultimately what we're going to need is sort of another buffer type of situation where we store key vector 3s for positions and scales, and then rotations, right? So we can have one buffer that stores all of our positions and scales. We can index into that, and then we can have another buffer that stores our rotations. And that will give us essentially what we need here. Both of those, interestingly enough, are going to be, and you know what though? We could actually have that be all one float buffer. That could be an F32 buffer, actually. And then we can just extract a certain number of bytes out of that and cast it to this structure and have exactly what we need. I think that actually makes a lot of sense, right? So let's start creating another section. I'm going to grab this again. And we're going to call this one animations. And we'll also go to the top and add our entry in here for animations. Right? So that we at least have this section down here. Now, for our animations, we are going to have, again, we're going to store some of this data per animation, right? So we have names. We need to keep that. So that's going to be string IDs of names of the animations. And then this is going to be animation counts. And then this is going to also be animation counts. And this is going to be animation counts. Same with this and that and that. Okay. So this is going to be string IDs and names of the animations. Okay, that's fine. The next thing is going to be yeah, I guess I'll just do them sort of in order. So this one is going to be durations, right? And so this is going to be 4 times animation count for the bytes, right? And this is going to be a F32. And an array of durations of each animation, right? And then we don't need that. So we have that, and then we have, I'm actually just going to use this again, and we're going to specify ticks per seconds, right? And so again, that's going to be the same size information, and we're going to say an array of ticks per second of each animation, right? So there's that. And then finally this here is going to be channel counts, right? So this is going to be channel counts. And then this is going to just be 4. This is going to be a U32, which again, that could probably be, that could be a U16. Again, we could save some space there. Let's optimize that. And so this is going to be an array of channel counts of each animation, right? So those are easy. The next thing that's going to be a little bit interesting is going to be how are we going to flatten this channel, right? Flattening the channels themselves should be relatively straightforward, but it's more so, you know, the channels themselves that we're going to count, or that we're going to have to flatten, right? So each channel contains essentially a name, and then a number of positions, a number of scales, and a number of rotations. Each of those are going to have to also store sort of a start offset into that array. So I'm going to have to think about that for a second. So how do we want to store each channel? I guess what we could do, we could store channels, right? And then we'll say size of channel times animation count, right? Size of, well, I guess it would just be channel. So we'll define that structure here in just a second. So what we're going to need is actually is a way to store channels per animation and reference them. So we kind of almost need like a think about how I want to structure that. Ilis, good to see you. How's it going? I think what we might want to do I'm trying to figure out a way to flatten these, right? So we need to flattening these is easy. Flattening these channels and then referencing them from the animation is not quite as easy. I guess what we could do, actually, I know, I've got it. So in our channel, each individual channel, we will have a animation ID, right? And that'll be a U16. So that will help us take the channel and connect it to an animation, right? And then also we'll have a use, let me see. I feel like for each one of these animation channels, this probably ought to be a U32. So let's do a U32 pause count, U32 rotation count, U32 scale count, right? So that's kind of what our channel looks like. So each channel has those things. And then I guess we could also include U32 offset, position offsets, U32 rotation offset, and then U32 scale offset. And then that offset would go into a flattened array of all positions, scales, and rotations. This would also have to have actually, I don't have to store this way. Come think of it. I could flatten this the way I've flattened the other data. Let's do that. So let's say we'll say channel data. Let's do, you know what? I'm going to actually replace what's down here with this. So let's do, we don't need a channel ID, right? But we do need an animation ID. So channel anim ID, right? So this is going to be a U16. This is going to be 2 times channel counts. We're going to need one more thing here. Total channel count. Right, and this is just going to be 2. So this is going to be the total number of channels for all animations. Right, so this will tell us how big each of these arrays need to be. So we have an array of 2 times channel count, total channel count, right? An array of animation IDs for each channel. And this should be total channel count. Right, okay, so we have the ID here. That's what we use to link a channel back to an animation. Okay. Right, and the rest of these are counts that work alongside of that. So we have channel position count. So again, that's going to be, I think I said I wanted to leave those as U32s. So that needs to be a 4. Array of position counts for each channel. Right? Okay, yeah, I think this is actually making sense. So we have this, and then we have channel rotation counts. And then we have channel scale count, right? Okay. And then the only other thing we'll need is probably offsets into that array. Where did my window go? There we go. Yeah, okay. So we have this, and then we have right after this, we'll do channel position offset. And that'll be an offset into the positions array for each channel, right? So we have that, and then we'll do the same for rotation. Rotations array, and then finally scale. And this should be plural all the way up because it's an array. Okay. So the array that these are mentioning there's two ways that we could do this. We could have one array that holds this vector3 key data and a separate one that holds this rotation data. Or we could split them, one for positions, one for scales, one for rotations. Or, since ultimately these are all F32s, we could jam it into one array and just pull out the number of bytes we need. Which is kind of the way that I am leaning towards. So in other words, we would have something like what we have up here. Let's see, where was that? This vertex data buffer, right? This essentially would be what we'd have down here. Right, so this is going to be channel data buffer. And essentially, this is actually only going to include F32 data. I guess we should probably say F32 array. So we're going to say F32s that stores all position, scale, position, rotation, scale for all animation channels. Overall size of this is determined by how many keys each channel has, as well as how many channels there are. Right. So, bytes extracted from this vary by the type of key data being extracted, i.e. a key vec3 extracts 4 F32s, whereas a key quat extracts 5. So, you know, this would be 3, 4, and this would be 4, 5. And then that completely flattens the structure. We don't have to have like another set of lookups like we have to do for channels. So everything here gets related back to its original animation by the animation ID there. And that should give us everything that we need to build out that entire section. I'm trying to figure out if I missed anything. Names. Did we put names in here? Channel names. We did not. What did Ingus? Okay, so you just grab this. So animation ID, I guess we can put animation ID first and then name. And we'll do channel name IDs. This is going to be total channel counts, and then string IDs of the names of channels, animation channels. And this is going to be total channel count. Okay. So now what we're left with is this. So let's see, we have our bones, our nodes, our animations. I wonder if I should separate this out into like a separate section for like all the channel stuff. Maybe I should. Right? Maybe we do. Maybe we do. Maybe we do this. Instead of having channels data there, we do animation channels, right? And do animation channels. And then animation channels. Yeah. I think that makes a little bit more sense. Okay. So here's all the sections of our format. I believe this is most of what we need. Oh, you know what? I did put material name IDs. Okay, cool. All right. So the only other thing that we have to put in here is our strings as far as our spec goes, right? And I wonder if I should include that in this spec or just kind of say, hey, this uses a serialized binary string table at the end. Maybe I'll put one more section in there that includes that. So let's do strings. And we'll go to the end. And I'll actually do this. And we'll do strings. And then under here, I'll just put a note. Strings are handled by a binary string table that is serialized into one large block of memory and is appended to the end of the file. Which actually makes me think we can actually eliminate something from the spec, I think. Since this is true, what we can actually do is this string count, actually, we don't need a string count. We need a string offset, which is the offset where the string table actually begins in the file. So that should be string table offsets. That's going to be 4 bytes, a U32. And we're going to do offsets in bytes where in the entire file where the string table begins. I think that makes sense. Champ, first time chatter, welcome. Discovered your series on YouTube, first time catching you live. Well, welcome. Appreciate you being here. Hope you're doing well. Let me see. Let me catch up on the YouTube side. Is it your own formats? Yes, this is our own format. We're actually we're speccing it out now, and we're going to be writing this. So the idea here is that we had sort of a static mesh, proprietary like binary format, and we were coming up with a format that was somewhat similar for animated meshes. And I'm like, well, when we think about this, like there's a lot of overlap in the data between those two. And so my thought was like, why have that separation when we should probably just unify into a single 3D format that either includes animations or doesn't. And then, we can just treat it as all one asset type and handle it accordingly. So that is basically what we're trying to do here. Now that I think about this, though, I just thought of something that isn't quite right. So our submeshes, our mesh type shouldn't be here. This should be global, right? This shouldn't be per mesh or submesh rather. So, when we determine vertex 3D, which is static, or skin vertex 3D, which is animated, that's not something we can define per submesh. That's something that we should define at the top level, right? And then that determines how we actually read our buffer data out of our vertex buffer. So we need to actually fix that. I was just thinking about that. That's not totally correct. This is the kind of thing I want to figure out before we start writing the code, right? So let me actually just fix this definition too, because that is an array of those things. Okay. So this doesn't belong here. This belongs up here. Let's see. Probably belongs like here. And then this is actually just going to be a single byte. And so this is going to be the type of vertex data in the file. We don't need this anymore because it's not an array. And then we can say IE 0 is vertex 3D format. 1 is skinned vertex 3D format. Okay. Doing great. Look through the engine as inspiration because I was trying to write a CPU rasterizer that renders to the terminal. That's pretty cool. Love the content. Really useful. I'm glad you like it. Thank you very much for the kind words. Welcome. Okay. So that makes sense to me. Trying to think if there's anything else we have missed. I don't think so. I think we've got just about everything. So we have animations, bones, nodes. Animation channels, submeshes. Yeah, I think we're good. I think that is the format. Now, I should say that's most of the format. There's a couple things that I want to do, though, to sort of help us in our debugging with this, right? Because there's going to be some things in here that can trip us up if we're not careful. And so I want to kind of think about maybe some checkpoints that we can have in this data format that will help us determine if we're actually reading the file the correct way. So, maybe some sort of guard between the different sections, for example. What to do in cases where we have zeros, right? Because that may very well be true. So, for example, we won't ever have, well, I was going to say we won't ever have a situation where we have zero submeshes, but maybe we want something that only contains node data for some reason. I don't know if we should support that or not, but maybe we should as part of the format. And if we don't wind up using it, we don't wind up using it. The more common case is going to be we have submesh data, right, which contains our vertex and index data, but we might not have like animation data or bones or hierarchical nodes or anything like that, animation channels, things like that. So there are going to be times where we're going to want to skip sections of this file, but we still want to have like markers sort of in between to say, well, yes, the header section ends where it should, and the submeshes section begins where it should, things of that nature. And so I feel like we ought to insert a couple of markers into the file, just to sort of give us that sort of security, right? So we could start off with just, I guess, some sort of guard that's in place, like a sectional guard. And so maybe it's some sort of number that indicates the section that we're in, right? So here we actually have, we have the header section, the submeshes section, bones, nodes, animations, animation channels, and strings. Like those are our sort of file sections, as it were. And so maybe we want some sort of divider. I don't know if we should have a separate beginning and an end. Can't hurt, I guess, right? So I guess let's try that. Let's think about how we might want to set that up. So we've got the header section. And so at the end of the header section, or I guess in between those two sections, we are going to have some sort of guard section. So I guess let's just take the first one of these, and we're going to put in sort of a separate table. We're going to put header and guard. Right. And this is just going to be a U32. I guess it doesn't need to be a U32. We could probably go with something smaller, but for now, that's what I'm going to do. So this is going to be, say, marks. I guess we can say serves as a checkpoint to ensure the end of the header section is where it belongs. Right? And then we can say the value must be And I guess we can do one for that. Yeah, I guess that makes sense, right? And then we can do another copy of this. And we'll do, actually, I should probably separate this one off. Now that I'm thinking about it. Separate it off into the submeshes section. So let's get this out of here. And we'll do submeshes begin guard. And we'll say that this one has to be set to 2. Maybe I ought to just roll these into the tables before it, instead of having it be separate. Yeah, I think I'm going to do that. I was thinking it might help formatting wise to have it separate, but now I'm kind of rethinking that. So let's just do yeah, okay. So serves as a checkpoint to ensure the beginning of the submeshes section is where it belongs. I think that makes sense. All right. So essentially, we're going to just kind of repeat this pattern. You know what? Instead of value must be, let's actually remove that. I'm gonna make this a little bit more dynamic. Let's actually not do an end and begin guard. Let's only do a begin guard, because we don't really care about checking where it ends. We just want to make sure that the next section begins in the correct place, right? So, if we think about the way that these guards need to work, the guard and the section itself should only exist if its count is greater than 0, right? So if the submesh count is greater than 0, then we should have a submeshes section. Otherwise, we shouldn't. So the guard itself should probably indicate what its type is, what the section type is. And then we can also use that to say, well, the section that we are expecting here is not the section that's actually present, right? So actually, yeah, we do want to have a value must be. Let's see. So value should indicate section type equals 1. Yeah, I guess we'll do IE that, right? let's see. Also, we'll put a note in here that says this section should only exist if submesh count is greater than 0. Yeah, okay, that makes sense. String table offset is string table is always going to exist, so I'm not too worried about that. But the other bits here should always exist if, yeah, okay. So this should be that. I guess I'll put these in here first. Nodes. And then animations. And then also animation count equals 0 and let's see, what did I call that? Total channel count. Ooh. Is greater than 0. But our total channel counts is here in the section that would need to check that. So that should actually be in the animation section. Okay. Okay, that makes sense. All right, so now we just need to put the guards in place. So this is the submeshes begin guard. I'm actually going to put, yeah, I guess we can keep with that naming scheme. So instead of submeshes, we have the bones one next. So this is going to be bones, and then we'll just increment this to 2, and then beginning of the bones section. You know what, let's simplify this. That's a little easier to deal with. Where was that other one? Here. Okay. So we'll take this and go into nodes, and we'll put a guard here. So this will be nodes, begin guard. Nodes section is where it belongs. We'll increase this to 3. And then we'll do animations. And then this will be animations. And step that up to 4. Did I do that correct last time? No, okay, yeah, I did. All right. And then one more down here for animation channels begin guard. And that needs to be 5. Oh, my bad. There is actually one more. Down here. All right, so we have the strings section here, but before that, we do have strings begin guard. Six. Now, do I need 4 bytes worth of data to represent those section types? No. But my thought is there may be other things that I want to encode into that at some other point. Some sort of other checkpoint data. And so I may need those at that point. So I'd rather just reserve it. It's only just a few extra bytes in the entire file. So let's see. Thoughts on these AI browsers that can go into agent mode? They seem useful, but will they stick? I doubt they'll stick, but to be honest, I don't use any of them. So I don't know that I really have a qualified opinion on that. My opinion on a lot of that stuff is I see AI embedded into it. It makes me not want to use it personally. All these companies are trying to embed AI into everything, and frankly, it's a bit tiresome. It has its uses for certain things, but like, yeah, I'm kind of like, just go away, leave me alone, let me do my thing. Like, I don't need AI incorporated into everything. I read an article about what a privacy nightmare the OpenAI browser is. Oh, I can only imagine. Yeah. Does that editor choose to give users a turn off AI button? See, but like, that's one thing that's always really annoyed me about software in general, is like, they come with all this extra crap and bloat that's like, you're opted in by default and you have to turn it off. Like, that's one of those things that, like, let me turn that option on if I want to use it, but it should be defaulted to off. Yeah. Yeah, I don't know. That's my thought. Like, all the integration that they've done of AI into Windows and stuff, it just makes me like not want to use all of that stuff. And Mac OS is doing it too, and it's really annoying. It's like, just like, let me turn that stuff on if I want to use it, but like, otherwise, don't even install it. Like, you used to actually have an option where you just didn't even want to install that stuff. Now it's like integrated with the operating system and you can't even turn it off. Or you can't even choose to not install it, which is super annoying. So yeah, I don't know. It's super distracting, super tiresome. To be honest, I'll be glad when the fad kind of dies off, because I think that's what it is. It's a bit of a fad. Like I said, it does have its uses, but Big Kano, how's it going? Welcome. Let me think. Okay, so do we have... So we've got all of our guards in for our individual sections. So that will give us a quick way to be able to verify that the format of the file is correct as we're sort of going through it. So, for example, if we're processing the file, we read the header, right? And then we come up to the next section of the file. And we've determined that for some reason the submesh count is 0, right? So the next section that we would be expecting would be the bone section if that was non-zero, right? But then we hit the submeshes begin guard, which would flag this as the submeshes section. We'll go, hey, wait a minute. Why is this section here because you told us that there aren't any of these things, it should not be here. So it's just kind of an extra way for us to be able to tell what's what and where we are in the file. Oh, I need to mark a lot of these things as arrays, actually. Which I guess centers and extents could technically come out of this vertex buffer as well, but I'm not going to do that. Let me do... Let's see, that was in the submeshes section. So that's here. So where we are giving the type of all of these things, these should all be arrays. Right? Wherever we're saying it's an array of something, we should probably just change the type to be that so that we're fully aware of what the heck we're doing here. This is extends 3D array. Okay. Looks like we did do that in the data buffers, which is good. The bones, I think this is going to be the same thing all the way down, actually. So the guard is a single one. The bone count. Wait, this is name IDs. So yes, we need that one. And then offset matrices, we need that. And then nodes. So node IDs is going to need that. Parent indices is going to need that. Local transforms is going to need that. Animations is going to have a whole bunch of things. So this is, let's see, that's just accounts. This is an array. This is an array. As is that. As is that. And then the channels themselves. Let's see. The channel animation IDs. This should be IDs. Plural. Yeah, so this is all going to be, these are all going to be arrays as well. Right, and then that is, okay. And then strings is kind of its own thing with the binary string table. Okay. So the nice part about this is this gives us a literal spec that we can follow when we go to actually implement the thing. And we yeah, I think we have everything we need. This is our blueprint to actually implement the whole thing. Been away for some time. How'd the surgery go? I haven't had it yet. I'm actually going to have to push it off till the beginning of the year for a few reasons, which I can't talk about yet, but soon. But one of those reasons that I can talk about is I just thought it was a little bit silly to try and do a surgery right before holiday season, when I'm going to need to be able to use both hands for lots of things. Yeah, the carpal tunnel surgery is going to be put off until January. In fact, I'm gonna reschedule that tomorrow, which sucks because it does hurt, but it's basically going to make it so that I won't be able to lift. I won't be able to lift, push, or pull more than 5 pounds of resistance with this hand at all for like 6 weeks. Actually, like 6 or 7 weeks. So, yeah, that sucks a little bit more, I guess. Still going to have it done, just have to push it off a little bit, just for, like I said, multiple reasons, which I will bring up when I'm able to. I'm just not quite there yet. Soon I'll be able to talk about it, though. But yeah, thank you for asking, though. I appreciate that. Your wife had the surgery. It was breeze and recovery was smooth. Yeah, I'm not too worried about that. It's going to be laparoscopic. It's mostly so I have to wear a brace for 10 days afterwards that I can't take off at all. And then it's going to be a pretty heavy weight restriction for like 6 or 7 weeks after that. And that's the part that, obviously I don't want to screw it up, right? So I'm going to stick to that. But like that's the part that's like I really have to think about and strategize around. Because it's like anytime there's something heavy around the house that has to be lifted, that my wife can't do, I have to call somebody else to come do it. That kind of thing. So, holiday season just didn't seem the right time to do that. It's just strategy stuff, because they said it's literally, I can't lift more than 5 pounds is what they told me. So, but yeah, I'm not really worried about like the surgery itself. It's more like just the period of time I have to wait before I have like full functionality back, so to speak, where I can actually, lift more than 5 pounds with it. Which 5 pounds isn't a whole heck of a lot. Like, I don't even know if I'll be able to shift my car. Like I've got a manual transmission in my car and I don't even know if that's like 5 pounds of resistance because it's got a fairly notchy gearbox in it. So, it's stuff like that I have to think about. Like, am I going to be able to drive my car? Or am I going to have to steal the wife's car all the time? Kind of thing. But yeah, thank you for asking about that. I appreciate that. And definitely when I have it done, you guys will see me. I'll have a giant brace on this hand, while I'm streaming. All right. I'm pretty happy with this. I think, what I'm going to do, I think I'm going to push this up as is, and then I'll start thinking about the implementation of this, or we'll start going over the implementation of it in the next stream. And so my plan for that is we have this animated mesh serializer that I was building. I'm going to build it in this. We're going to rename it afterwards. And we're also going to change the asset type afterwards. We're going to get this working. We're going to get the animation system working off of this, and then I'm going to port over the static mesh system to use this asset format instead, which shouldn't be too big of a deal. Because the ultimate asset itself is actually very similar between animated and static meshes at this level. So that shouldn't be too big of a deal. But I know I'm not going to make it through too much code in like 10 minutes. So I guess I could start thinking about like some of the structures I need for this. I guess we could do that. All right, so yeah, you know what? Heck with it. Let's do that. We'll start thinking about some of the data structures that we're going to need, and then we'll go from there. The Coppinger raided with a party of 61. Thank you so much for the raid. I appreciate that. How's it going? Welcome, raiders. Thank you so much for the raid. Let me give a shout out. What have you been up to on stream? Do it live. Nice. Bill O'Reilly. I love the reference there. That's hilarious. You went to Parliament on a bike to join a protest, but it ended. Oh, that's kind of awesome. Awesome. Well, welcome, raiders. So I should probably give a quick introduction as to what the heck we're doing. So we are on this channel working on a game engine that we've written completely from scratch using C and Vulkan as our initial rendering backend. And so it started off as a tutorial series, and we've kind of changed formats over time to figure out what works, what doesn't work. Ultimately, we landed on this live stream format that you see here. We've been at it for a while. The engine itself is free and open source. It's available on GitHub. Here, by the way, is a link to the page that we're looking at. And so the engine itself, like I said, is free and available. Although it's very early days, so I wouldn't say it's production ready yet. It's got a basic PBR pipeline, cascading shadow maps, custom UI system. All this stuff was built from the ground up. The engine itself is Apache 2.0 license, which means you can use it for whatever you want, whether it be personal or commercial.
It's been a while since I've been able to tune in. Hope everything is going well. I have begun my yearly engine rewrite from scratch based on everything I learnt before. I look at my code and think, WTF did I do before? Game timeline pushed one more year, Kappa.
Tielman, thank you so much for that. I appreciate that. 23 months. Thank you very much for the tier 1 sub. And yeah, I definitely appreciate where you're coming from. So yeah, the engine itself can be used for personal or commercial purposes. It does not matter. All I ask is that if you use it, you say you used it. So a couple more details about it. It is cross-platform, so it runs on Windows, Linux, and Mac OS. We do have other platforms planned for the future, but for now, those are the main 3. The idea behind this is it's educational, so it's a way to build a game engine. It's not the only way to build a game engine, but we walk through the entire series, or the entire process rather, including design and all that other stuff of building a game engine from scratch. And all of the debugging, troubleshooting, all of that stuff that goes into it is all included live, right? So we do have a YouTube channel as well, where all of the VODs are, so it's all completely available out there. The engine itself will always be free and open source. It'll never have any royalty fees or licensing of any kind. Nothing like that. It's designed to be an educational resource, that kind of thing. I think should be free. We need a competition in this space. And so this is one way that I'm hoping to motivate folks to want to get into this space and create some cool stuff. And so we do have a Discord server. It's about 1,000 people. And then I've got, some other links on here. I don't have any sponsors or anything. It's just you guys. So, there's no corporate shilling going on here of any kind. Aside from that, the first game that we are making is a game called Shadows of Illumina. We've started writing out a game doc to get some of the requirements that we need for the actual game. This document includes some basic lore and whatnot, as far as background story to the game, world building, things like that. We've done some of that. We've actually mapped out some stuff in terms of world map. Let me actually pull that up so you guys can see that. Give me 1 second to get that loaded. This one. All right, so that just takes a second to load. But we started kind of creating a world map and what this might look like. So the game itself is going to be a 3D isometric action RPG. And this is a bit what the world map is going to look like for that. So we've got a couple of continents here that we've started mapping out. And we've got a little bit of story already built up around that. And so we're basically just going back and forth between game dev and engine dev because the game that we're making is sort of the test driver for the engine. And so one of the last systems that we needed to get in before we could fully get into the full swing of development is an animation system to support animated meshes. And so we were on this stream, we were going through creating our own 3D model format from scratch and defining how that's going to be laid out. It's a binary file format, what the different sections look like, how the data is going to be laid out, various buffers of data that are going to be located in the file, how to access that data, all of those things. things like submesh data, bones, nodes, animations, channels with keyframe data, that kind of thing. And so we just finished this up on stream. And so we're going to be implementing this on the next stream, and we were getting ready to talk about some of the data structures. And that's kind of where we left off. So I hope that all makes sense. Incarnate, I use this too. Yeah, Incarnate is pretty awesome. I actually wound up paying for it because I just yes, they have a free version, but the project is so awesome that I thought it was worth supporting. So I went ahead and did that. Certainly pushed me into making an engine. Yeah, that's awesome. That's what I'm hoping to do, right, with all of this. Wish they had a desktop app. Yeah, me too. Although, to be honest, if they had a desktop app, it would probably be some awful thing that's Electron based, right? Which wouldn't really be any different than this anyway. Except maybe it'll load faster if it stores the data locally. But, anyway. So yeah, that's kind of what we're working on. I really appreciate the raid. Thank you so much. So yeah, this is, I haven't shown this too much recently, but we actually made quite a bit of this on stream as well. And there's like a whole, like I said, there's a whole bit of lore behind the world setting. Like this section, all of this text from here, all the way down here to here talks about like all of the various tribes and cultures and zones and wars and stuff like that that's happened. All of that kind of stuff is included in there. And then we talked about some of the mechanics we want to add. We actually created our own sort of lightweight database for item information and localization and string handling, that kind of stuff. So yeah, we've done a lot, and we've done a lot of sort of building the groundwork for the game. And so I'm hoping sometime here very soon we're actually going to get full swing into actual game development, where we can actually start building some of these systems and roaming around the world and start actually being able to build out the world. Let's see. Apothem, you've been programming way too long. Today, Vulkan swap chain was going crazy with errors. Turns out I deleted the parentheses around something without realizing. Oof. So order of operations error then. Nice. New tool added to my bookmarks. Yeah, Incarnate is awesome. And I think it's, I forget exactly what tier I got. I think it's like $25 for a year or something like that. It unlocks like a lot more little stamps and stuff that you can use. And so it was such a well-built project. I'm like, you know what? I want to support it. And I just got it. It's well worth it. Wasn't even the one to figure it out. My wife thinks that programming is black magic, looks at the code and just goes, PEMDAS. The old math. Yep. That's hilarious. So she actually looked at it and figured out what the, so it was a PEMDAS issue. Yeah. That's funny. I know what you mean, Apothem. My wife has actually done that for me a couple of times. She's just been like, wait a minute, shouldn't that be a less than sign instead of a greater than? I'm like, damn it. Sometimes you're just looking at it too long and you're just like, your eyes just kind of glaze over and you just miss stupid stuff like that. Happens to me all the time. All right. Well, anyway, so that is the introduction to the project. So, welcome Raiders. If that sounds like it's interesting to you, I would really appreciate a follow, either on the Twitch side or the YouTube side. My whole goal with this is to make and release, a game on Steam. So Steam is going to be the first platform that I'm going to release through. Probably the Epic Store at some point in the future, and then maybe some other forms of distribution, like maybe itch or something like that as well. But the idea for this is we are going to take a game all the way to release, and we're going to make it as polished and professional as possible. But we will, by the time we're done, we will have built all of the tech ourselves from the ground up. No ASCII art for the layout of type 010. 0 out of 10. That's funny. I mean, we could put ASCII art in there somewhere just for the lulz. Okay, so like I said, I was going to get started on this. However, I do have to be up in the morning for work. So that means, unfortunately, I have to end the stream. But I will be back tomorrow night around this time. So I actually will start, I usually say I start 9 p.m. Eastern. Sometimes I get started a little bit before then. And so I will be back tomorrow night. And we will actually get into implementing this. And it should be a fairly interesting implementation. I'm tempted to throw out sort of the implementation that we had here and just write it from scratch. But yeah. I think that's kind of the plan. So I'm going to find, start every NPC dialogue with "you're absolutely right." I could do. Yeah, stream's ending, unfortunately. Yeah, I really appreciate the raid. Unfortunately, you know, I do have to get up in the morning and do work things. Just the reality of life, right? I'm not at the point where I can do this full time, unfortunately. But you know, it is what it is. So let me find someone to raid. I'm going to try and find somebody that is doing something somewhat similar to us, if we can. If not, I see who we might go with. Actually, I think I know who I'm going to raid. Just let me scroll through the list really quickly. Yeah. Okay. We're going to go with Z.A. Shaw. Because he is doing C++ game dev, which is somewhat related to what we're doing. He's doing C++ at versus C, but yeah, it looks like he's deep in some UI code, so we're going to see what he's up to. But yeah, thank you guys so much for joining. I really appreciate it. We'll see you guys back here tomorrow. And yeah, see ya.